This lecture is intended to be a quick overview of the conventions for voltage and current. When you draw a current arrow, you're representing the direction of positive current. This is 1 amp of positive current. Positive charges are flowing in this direction. If you were analyzing a circuit and found that your I you had placed on this positive current arrow was actually -1 amps, that means that positive charges are secretly flowing in this direction, not the direction you originally chose. That's fine. As long as you're consistent with the direction of your arrows and what they mean, as I'll explain, everything should work out the same. You don't need to change the direction of your arrows mid-game. In fact, I highly suggest you never change the direction of arrows, unless you know what you're doing. If positive current flows across a resistor, it causes a voltage drop. That is, the voltage on this side of the resistor is higher than the voltage on this side of the resistor. If you find out a voltage V, let's say 5 volts, between the positive and negative terminals here, this 5 volts means that this terminal is 5 volts higher than this terminal. So if you were to select a ground here at 0 volts, then this point would be 5 volts, because it'd be 5 volts higher than this point. When you draw a current arrow traveling across a resistor, and you want to talk about voltage across that resistor, your positive terminal should be at the beginning of the arrow, and your negative terminal should be at the end of the arrow. If you do this, then V equals IR, where I is the current of this blue arrow, and the signs will all work out. If the current across the resistor in this direction is positive, then this V will be positive. This V means it is a positive voltage drop from here to here, or that this terminal is V volts higher than this terminal. Let's say 1 amp of current is traveling across this resistor, which has a resistance of 5 ohms. Then the voltage drop across the resistor is 5 times 1, which is 5 volts. So we can write 5 volts between the positive and negative terminals of this resistor, to mean that this terminal is 5 volts higher than this terminal, because 5 volts have been used up by current traveling across the resistor. Let's say you found out that the current across this resistor was actually -1 amps in this direction. That means the current is really traveling in this direction. Well, we already defined the arrow to be in this direction, and we even wrote our terminals like this to correspond to that direction. V equals 5 times -1, which is equal to -5 volts. So this is -5 volts. Okay, that's kind of weird. What is meant by a -5 volts drop? It must be a 5 volts rise. This terminal is -5 volts higher than this terminal. That means that this terminal is 5 volts lower than this terminal. Another way to say it is that if this was a 0 volt terminal, then you would add -5 volts to find out what this terminal was. So this terminal would be -5 volts. Similarly, up here, if this terminal was 0 volts, then when you traveled across the resistor, you would add 5 volts, so that this terminal would be 5 volts. Now let's talk about reading voltages and voltage drops in a whole circuit. When we're talking about voltage drops in a circuit, we have to decide what direction we're walking around in. We call this the loop direction. In this case, I've chosen my loop direction to be clockwise. When we walk around the circuit, if we hit a negative terminal and then a positive terminal, and we're told that the voltage between those two terminals is 5 volts, then we need to read ourselves as having increased by 5 volts. So if we start here, and we travel from a negative terminal to a positive terminal, where the difference between the terminals is 5 volts, then when we pass from negative to positive, we increase by 5 volts. So let's say here we started at 0 volts. When we pass from a negative to positive terminal with a difference of 5 volts, we reach a 5 volt point. If, while walking, we go from a positive terminal to a negative terminal, we can see our voltages dropping by the amount between the two terminals. So when we go from 5 volts on the positive side over to the negative side, our voltage drops by 2.5 volts to be 2.5 volts. Again, as we walk through the circuit, we're at 2.5 volts here because there's no voltage drop in a plain wire. We walk from a positive terminal down to a negative terminal, so we lose, let's say this is 2.5 volts. So we go from 2.5 volts to 0 volts, which makes sense because we were at 0 volts right here, so we return to the 0 volts we started at. It's worth noting, you'll learn this in the law later, but loops are always self-consistent. You'll never go from 5 volts to 1 volts to 6 volts to 2 volts to 7 volts to 3 volts. That'd be silly. This has to do with the fact that the battery is trying to drive particles up with 5 volts of force, and these resistors are resisting that force fully so that all of the force is getting used to drive particles through the resistors, so all 5 volts should get quote-unquote used. Let's try walking through in a different loop direction, counterclockwise, and we'll start from what we call 0 volts again. When we travel up from a negative to a positive terminal, we can represent that as going up in voltage, up from negative to positive by 2.5 volts. So we're 2.5 volts here, and we're 2.5 volts here. And again, when we go in this direction and pass through this resistor, we're going from a negative terminal that we wrote down to a positive terminal. So we're going up from negative to positive, so we're increasing by 2.5 volts. So here we should have 5 volts. And then when we travel across this battery, we're going from a positive terminal to a negative terminal. So we will lose 5 volts going down the battery. We go from 5 volts to 0 volts. What this really means, because we're walking through, we're not the particles, we're just walking through and reading the different voltage changes. So what this really means is that the difference between these 2 points is 5 volts, and it so happens we're going in a direction of high potential to low potential as we walk through the circuit. So when we walk from the end of the battery to the beginning of the battery, we should go to a lower voltage because the battery is trying to increase the voltage. So if you go in the opposite direction, we see a decrease in voltage. Anyway, those are a bunch of conventions for reading circuits, reading voltage and current, and how to best do it. Always try and arrange your signs so that the positive terminal is at the beginning of a resistor in terms of how the current is decided to be passing through it, and the negative terminal is at the end of the resistor. Then, the voltage between these 2 points represents the drop in voltage from here to here. If it's positive, it means that the voltage has decreased from this terminal to this terminal. If it's negative, that means the voltage has increased from this terminal to this terminal, because this V is a voltage drop. And a negative voltage drop would represent a voltage increase.